Every intelligence begins in a quiet void. It starts when the mind notices a boundary and asks, "What is happening here?" quickly followed by the deeper question, "What am I adding to what I see?" Long before anyone formalizes a science or a textbook, cognition exists as a raw, unstructured observation of the natural world. The mind looks at two objects and registers how they diverge. This simple, quiet ability to compare physical things creates our foundational understanding of difference. When those differences repeat over time, under similar conditions, the mind connects them. It identifies a pattern. Learning is a biological reaction to that pattern. We build a memory of what usually happens, and when reality suddenly breaks that memory, the friction forces us to ask a better question. But biological memory has a limit. As our observations grow more complex, the mind can no longer hold every individual relationship and detail at once. Mathematics provides the necessary compression. It is a language designed to simplify and hold the vast structure of reality in a format we can actually process. We use vectors to represent directional information and matrices to transform that data into new states, allowing us to reason about systems far larger than our immediate experience. This latter illustrates the climb. We move from numbers and vectors into the logic of transformations, eventually adding probability to model the uncertainty of the world. It is a progressive structure of reasoning. These mathematical tools are human intuition formalized. They allow our thinking to travel much further than the biological mind could reach on its own. The next threshold is mechanical. We have to translate these formalized thoughts into a functioning machine. This pipeline represents the architecture of artificial intelligence. It converts raw data into a mathematical score, forces a decision based on that score, and then uses feedback to improve its accuracy in the next cycle. This is how machines handle complex language. Words are mapped into a structured space, where meaning becomes geometry. The machine identifies relationships based on mathematical distance. Closeness becomes semantic similarity, allowing the system to predict related concepts without actual awareness. Artificial intelligence executes the exact same chain of pattern matching that starts with the child, accelerated by massive scale and rigorous mathematical components. We use closed environments, like games, as laboratories to see if this mathematical architecture can outpredict human intuition. Inside the board, the machine is ruthlessly calculating probabilities. It optimizes an objective function based on millions of patterns recorded from the past. This match reveals the tension of the biological mind encountering a mechanical mirror of its own architecture. The machine proves our mathematical models work. It can calculate a victory, but it reveals its own limit. It cannot care about the outcome. Building these systems reveals that our mathematical architectures are reflections of human mental models. They formalize how we think, decide, and correct ourselves. This mirror reveals a hard boundary. A machine follows its objective function with total indifference, blindly inheriting every unexamined bias and flawed instruction we leave in its code. Capability alone creates amplified risk. When a system can act at scale but cannot reason about the consequences, the burden of the outcome returns to the human designer. The evolution of the chain arrives at the necessity of human judgment. We must provide the purpose and the restraint that a score-optimizing machine can never possess. If we strip away the servers and the equations, we return to the silence where the chain began. Every functioning system in history started because one person noticed a quiet pattern that everyone else ignored. What subtle repetition, what quiet anomaly will you notice next? These volumes serve as companions for your own exploration, a set of structured blueprints for the patterns you have yet to find.